K-Water is a public company specialized in water resources management. We provide various international water education programs for the developing countries to solve water-related issues all around the world. Today's lecture is about an overview of hydrological investigation and how to implement this by activity. Water, an indispensable resource for human survival. In recent years, it is becoming more important to prevent extreme floods and droughts caused by rapid climate change, manage river environments, and resolve water-related conflicts between regions. This requires understanding the importance of hydrological investigation as a starting point for water management. Hydrological investigation refers to the observation, measurement, and investigation of hydrologic cycle factors, such as precipitation and water level, to quantitatively figure out the hydrologic cycle process. In the past, only precipitation, water level, and flow were investigated to prevent floods and drought. However, recently, the hydrographical investigation is performed to identify environmental factors, such as hydrological cycle structure, installation and use of river facilities, water quality, and water ecosystem in the river basin. Since the use of inaccurate hydrological data may cause property or personal damage, it is essential to obtain and provide data through accurate hydrological investigation. The hydrological investigation is carried out for a total of 6 parameters: precipitation, water level, discharge, sediment load, evapotranspiration, and soil moisture. Let's find out how to investigate each parameter. Let's take a look at precipitation. Precipitation refers to the amount of rain, drizzle, hail, frost, snow, etc. that fell during a specific period, expressed in depth per unit area. Let's take a look at the tipping bucket rain gauge, the most widely used measurement device. The principle of the conduction type rain gauge is as follows. When a certain amount of rainwater is collected in the collection cup through the water inlet, the cup tilts and drains into the reservoir, and the amount of precipitation is recorded according to the number of conductions. Recent conduction-type devices have built-in heating wires that melt snowdrifts to measure snowfall during the winter. The water inlet of the rain gauge must be positioned horizontally at least 30 centimeters or higher from the ground level. Check the water inlet of the conduction-type rain gauge for internal damage, deformation, rust, etc., and check the mesh regularly to ensure any problem with the measurement of precipitation. Be careful not to damage the rain gauge when cleaning, and check the drainage hole clogging, horizontal position, and screw loosening. What is water level? Water level refers to a measure of the height from a given reference to the surface of the water. Among the various water level meters to measure the water level, let's look at float level gauge, pressure type level gauge, radar type level gauge, and reference water level table. The float level gauge measures the water level by rising and falling of the steel wire connected to the float on the water surface according to the water level change. The float level gauge should be installed to measure from the lowest water level to the highest. At this time, the observation well and the conduct pipe should be placed together. To ensure that the water level can be accurately measured, it is necessary to check if the pulley is rotated, the pulley shaft is fixed, the soil is deposited in the race entrance and manhole, and conduit surface is exposed, and the wire is slippery. The pressure type level gauge measures the water level by using the change in the pressure received by the water pressure part of the level gauge installed underwater. Level gauge should be firmly installed using protective steel pipes to prevent loss by flooding, etc., and care should be taken not to break the cable. Check whether the measuring unit is properly buried, whether there is sediment, and whether the cable is disconnected, etc., to ensure that the water level is accurately measured. The radar-type level gauge measures the water level as follows. Microwaves from the electromagnetic generator are transmitted by the antenna system of the radar sensor to the measured water, reflected by the water surface, and received back by the antenna system. The time from emission to reception of the signals is proportional to the water level. The radar-type level gauge has a large error as the distance from the electromagnetic generator to the water surface increases. Therefore, the height of the installation point and the site condition should be taken into consideration. In order to accurately measure the water level, it is necessary to check the fixation of the water level, foreign substances to the electromagnetic generator, and the power supply. The reference water level table refers to a leveling rod installed to observe the water level and must be installed as a standard value for water level observation. When installed, it should be convenient, secure, and stand out to identify the scale. Security, visibility, and loss of scale should be checked regularly. Discharge refers to the volume of water that passes through a cross-section of a river per unit time and is measured by foot, ship, bridge, or cableway, depending on the type of hydrometer. The rotary hydrometer should be used in shallow and slow-flow streams as the operator walks directly into the water for measurement. Make sure to wear safety gear such as chest boots, life jacket, whistle, and safety helmet to avoid an accident when measuring the stream flow. The rotary hydrometer measures the discharge of the river using the number of rotations of its propeller. The rotary hydrometer consists of a hydrometer, rod, and user terminal. Fix the hydrometer to the rod and connect the user terminal to measure the discharge. The hydrometer should be kept as far away as possible from the operator's body to avoid obstructing the flow of water. Repeat the measurement while crossing the river. The discharge is calculated by multiplying the actual measured velocity and the cross-sectional area of the river by the depth and distance of each measuring point. Electromagnetic surface hydrometers are used in bridges, especially when the water is deep and the flow rate is high, such as in the flood season. When using this way, make sure to install a rubber cone and tripod for vehicle control and wear a fluorescent vest, safety helmet, and rain jacket. The electromagnetic surface hydrometer uses the Doppler effect of the reflected wave to measure the flow velocity by generating electromagnetic waves to the water's surface. It consists of a hydrometer, a tripod, and a user terminal. Fix the hydrometer to the tripod and connect the user terminal to measure the flow velocity. The hydrometer should be installed facing the upstream of the river and repeat measurements while moving to various places considering the width of the river. The electromagnetic surface hydrometer cannot measure the depth of water, so streams must be measured before flood season. In conclusion, the discharge can be calculated using river survey data, the distance by measurement location, and measured velocity. ADCP, Acoustic Doppler Current Profiler, is using a ship in a river with wide and deep water. Use a small uncrewed boat that can be controlled by wireless, and the operator must wear safety gear before measurement to prevent an accident. ADCP is a device that measures a three-dimensional velocity distribution using the Doppler effect of ultrasound. It is measured across the river, so it is necessary to regularly check the condition of the sensor, the depth, and suspended solids, which can cause measurement errors. It can also quickly and simultaneously measure three-dimensional velocity distribution, depth, cross-sectional area, and flow, even on wide rivers. Sediment load discharge refers to the amount of soil transferred according to the flow of the river, and theoretically it is the sum of the suspended load and the bed load. The suspended load refers to the soil that floats from the floor by the flow of the water and moves underwater. The bed load refers to the soil that rolls or slides to the bottom surface or moves along the bottom surface. The sediment load measuring unit is divided into the suspended load collector, the bed load collector, and the tractional load collector. It should be combined with flow measurement for analysis of sediment runoff and stiffness fluctuation of the watershed. The suspended load should be measured considering the depth and flow rate of the river. If the water is shallow and the flow rate is slow, the operator can directly enter the river to measure. If the water depth is 4.6 meters or less and the flow rate is fast, a depth integrator should be used. When the depth is more than 4.6 meters and the flow rate is fast, a point integrator is used. When flow rate is very fast, the water surface sediment collection method can be applied. The suspended load collector is divided into a depth integral suspended load collector and a point integral suspended load collector. The depth integral suspended load collector is an equipment that evenly collects the suspended load at each location while moving the collector from the bottom to the surface. There are round-trip sampling that collects both when rising and falling, and one-way sampling that collects only when falling. The point integral suspended load collector has an electrically operated valve. Therefore, it can collect the suspended load at any point on the vertical sideline or only from a portion of the measurement section. The bed load measurement is a method of unloading equipment on the riverbed and collecting soil for a period of time. The tractional load collector collects soil from the bottom by lowering it on the riverbed. The inside of the tractional load collector has a ladle-type bucket, and when the collector reaches the bottom, the bucket closes and the tractional load is collected. When collecting the tractional load, care should be taken not to disturb the riverbed, and if possible, use a vehicle or a hoist at the location where the flow rate is measured. Evapotranspiration is the sum of the amount of water vapor evaporated from the ground or water into the atmosphere for a certain period of time, and the amount of water vapor evaporated from the leaves of plants into the atmosphere. The eddy covariance method is applied to calculate the amount of evapotranspiration. First, build an observation tower on a homogeneous and flat area, and install a 3D ultrasonic wind sensor and a gas analyzer for measurement. Eddy covariance method analyzes wind speed and water vapor concentration with a gas analyzer to calculate evapotranspiration at a certain period of time when the wind moves with water vapor. When installing the observation tower, considering the type and height of surrounding vegetation and the weather conditions, it must be carefully installed so that evapotranspiration can be calculated to represent the watershed. Soil moisture content is the amount of moisture contained in the soil, which is complexly affected by geological conditions, hydrological conditions, and vegetation distribution. Soil moisture content provides significant data for hydrological and erosion models. At the same time, it is an important factor in the hydrological process to understand the water cycle process. It also plays a crucial role in penetration, evaporation, transfer of pollutants, and dynamics of the ecosystem as the most significant factor in soil-water balance and ecological hydrology due to its interaction with vegetation. To measure the moisture content of the soil, a dielectric constant measurement method is used. Electromagnetic waves are generated from the metal probe to the installed soil layer, and the probe detects and measures them. TDR sensor measures using the time difference of electromagnetic waves by properties of the dielectric constant measurement method, which has a high stability and accuracy and can be measured in real time. It should be installed in a place with a relatively homogeneous soil layer representing the soil and geology of the surrounding area. Today, we have an overview of the hydrological survey and the actual survey method in the field.